Okay, today we're going to look at more exponent rules. Last time we looked at this rule, and we saw this is really easy to see. If I have, say, x to the fifth times x to the sixth, then if I expand it out, I just have x, that many 5 factors of x and 6 factors of x. And if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you have 11 factors of x, which is the same thing as 5 plus 6, x to the 5 plus 6, which is x to the 11th. Okay. And you can see in general, it's the same idea. If I had, let's take this just in general and don't use a specific example. If I have a factors of x, I have a of these x's, and then I have b factors of x. I have b of these. So then how many factors of x do I have? Well, obviously I have x plus a, or I mean a plus b factors of x. That's pretty easy to see. Okay, the next rule is going to be the division rule. And when I have this, I have x to the a minus b. And that's, again, really easy to see with a concrete example. If I have x to the fifth over x to the second, then I'm going to have 5 factors of x here over 2 factors of x here. These 2 factors of x cancel those 2 factors of x, and I obviously get x to the third, or x to the 5 minus 2. So there's my 2 rules that we've got so far. Now, let's work some problems with those 2 rules, and then we'll take a look at what happens when this number right here is larger than this number. So an easy problem here, all of this times all of this, I can turn that into 3 problems and just go 3 times negative 4, x squared times x cubed, and y cubed times y to the 5th. So altogether I have 12, 2 plus 3, x to the 5th, 3 plus 5, y to the 8th. Now, let's take a problem where we've got division and multiplication involved. Well, or just a division problem. Let's do one of those. So suppose I have 28 x to the 5th, y to the 3rd over 21 x squared y to the 1st. Now, in this problem, we broke this up into 3 problems. We took 3 times negative 4. Then we took x squared times x cubed. And then we took y cubed times y to the 5th. Well, let's do the same thing. Let's go 28 times 21. Let's break this problem up into 3 problems and work each one. X to the 5 minus 2 and x to the 3 minus 1. Well, this will reduce. I could take 7 into both of those. So I'll get 4/3 x to the 3rd. Oh, I'm sorry, this should have been a y. And y to the 2nd. There we go. Or you could have written it like this too. 4x cubed y squared over 3. Either one would probably be okay. This might be preferred. Okay, now let's take a problem now where we combine the multiplication and the division rules together and see what happens. Now here's our problem. We have a multiplication up here, and then we have a division. So why don't we imagine there's a parentheses around here and just do this multiplication first. Go ahead and do that and then come back. And you should have got 3 times 4, x squared times x cubed, y cubed times y cubed over 6x to the fourth, y to the fourth. And then that would have been 12x to the fifth, y to the sixth, because I'm adding my exponents by using my multiply rule, over 6x to the fourth, y to the fourth. So then down here I'm getting 12 divided by 6 is 2. So then this is x to the fifth minus 4, and this is y to the sixth minus 4, which is then 2x to the first y squared. Now, what happens when b is larger than a? In other words, if I had, say, this problem, suppose I had x to the third over x to the fifth. Watch what I'm going to get. X to the third over, x to the 3 minus 5, which is x to the negative 2. What is that when I have a negative exponent? You can see very easily that what it is by just expanding the numerator. X times x times x, x times x times x times x times x, and I get these 3 x's canceled, these 3 factors of x, and I get 1 over x squared. Now, here'd be another way to do that. Let's do it again. And let's go x cubed over x cubed times x squared. Now, isn't it true? X cubed times x squared is x to the fifth. And x cubed will cancel x cubed. X cubed over x cubed is 1. So that leaves us with 1 over x squared. Now here's the deal. If we've done everything right, by the division rule, we get this. By the canceling rule, we get this. So 1 over x squared must equal x to the negative 2. So x to the negative something, negative a, equals 1 over x to the a. Okay, let's do this one more time with 4 problems, 4 or 5 problems, and I think you'll see how the pattern. Now let's look at these 5 problems. According to the division rule, this would be x to the 4 minus 2, which is x squared, which you can see very easily when you use the cancel. X squared times x squared over x squared. These cancel and you get x squared. Makes sense. This is x to the 4 minus 3 equals x to the first, and you'd have the same idea here. X to the third times x to the first over x to the third. X to the third's canceling, you get x to the first. Now watch what happens here. It's a little unusual. X to the 4 minus 4 equals x to the 0, but the canceling gives you a 1. Therefore, that tells us that x to the 0 equals 1. Well, that gives us a new rule. Anything to the 0 equals 1. And then we continue on our pattern. This should turn out to be negative x to the negative 1, shouldn't it? X to the 4 minus 5 is x to the negative 1. And x to the 4 minus 6 should turn out to be x to the negative 2. And canceling, we'd see we had x to the 4th over x to the 4th times x to the 1st. Cancels, cancels. There's a hidden 1 there. A hidden coefficient of 1. 1 over x, so 1 over x to the 1st. That's that rule right there. And this is 1 over x squared. There's that rule again right there. Okay, now let's try a problem. Okay, now here's your problem. And you probably should do the numerator first as a multiply rule, and then do the denominator next as a multiply rule, and then do the numerator over the denominator as a division rule. You try it. And your intermediate step should look something like this. Now notice, I'm doing this part in my head. I'm not doing that part in my head. So let's finish it out. 20x to the 5th and y to the 10th. That's a 6 right there. And then here I have 6x to the 7th, y to the 6th. Now notice, where did I get that 6? Well, there's a hidden 1 right there. Y to the 1st is the same thing as y, so 5 plus 1 is 6. Then if I take the 3 problems here and do them, this first problem, divide by 2, I get 10 over 3. And here I get x to the 5 minus 7 would be negative 2. And here I get y to the 10 minus 4, or minus 6 is y to the 4th. Now, that's an okay answer, but chances are they'll ask you to put it in positive exponents. Maybe not. So then this would be 10y to the 4th over 3x squared. That might be your better answer.